So guys, good evening. Let us start with the another topic of climatology, that is the uh, vertical distribution of temperature and the lapse rate. Let us begin. So we have seen the horizontal distribution of temperature already, and we know that it is an important type of distribution of the heat, and it controls the atmospheric and climatic systems. Now, when we talk about the vertical distribution of the temperature, so it means what is the variation in the temperature with height or altitude. Normally, we have come across the fact that with height, the temperature decreases. So with elevation, the temperature decreases. This is a known fact. But is it really like that? That is it a direct relationship that as you go up in the atmosphere the temperature will always decrease? So it is not like that. It's a very complex process, and there are a lot of variations as the factors that control this change in the temperature are numerous. So first let us have a look at this term, temperature gradient. So basically, temperature gradient is a physical quantity that describes in which direction and at what rate the temperature changes the most rapidly around a particular location. So let us say we are standing at this location, and then as we try to measure the temperature of this particular locality with height, what will be the change in temperature? That is called as temperature gradient. It is a dimensional quantity expressed in uh, Kelvin per meter, that is the SI unit, but normally we for the common use it is measured in degrees Celsius per kilometer. So it is approximately average value is 6 degrees Celsius per kilometer. That is the vertical temperature gradient. Now, this temperature gradient is partly controlled by the energy transfer, energy transfer, and then partly by the vertical motion in the air. So, what does this mean? So, it means that in this column of air, okay, as the air starts to rise, we have seen that as the air starts to rise, so as this vertical movement of air takes place, we know that the on rising the air expands. Now, once this expands, normally the air becomes cool. So we this is a universal fact without any exception that rising air it cools while sinking air sinking air it warms. So there is no exception to this rule. As the air rises up, it becomes cooler, and as it sinks, it becomes warmer. So once the air starts to rise, then it may give its energy to the surrounding areas also. So that particular air column will lose heat and temperature will go down. So this variation, so let us say at the surface the temperature was T1, and at some height H the temperature was T2. So this gradient, so definitely as this air is rising, T1 will be more than T2. So how much this change in temperature has occurred? So that will be T1 minus T2. This will be the temperature gradient for that particular height and location. Now, in this case, uh, a very important fact is the pressure systems. Okay, we all know that force per unit area being applied by the atmosphere is called as the atmospheric system, and once the pressure is high, the air will start moving from high pressure to low pressure, and once the pressure is low, then it is reverse. Now this pressure system plays a very important role in the temperature gradient. it has been seen that once the pressure is low, then the air starts to rise. So once it rises, it means that the air will quickly lose heat. So at the surface where the temperature was T1 and at the height where the temperature was T2, the difference between these two temperatures will be quite high. Okay, so for example, if at the surface the temperature was 25 degrees and at a height of 2 kilometers the temperature drops to maybe 0 or minus 2, then this there is a certain difference in temperature. Why this is happening? Because once the air is rising, it rapidly starts to expand. So this expansion of air causes the air to cool down quickly. On the other hand, once it is a high pressure system, the air starts to sink. Once this air starts to sink, it gets contracted. It doesn't expand now, it gets compacted. Due to this compaction, the temperature of air starts to rise. As a result, the gradient becomes less steep. So in the case of a high pressure system, this temperature T1 and T2, this difference is not much. So in both the cases, we will have a look at T1 and T2. So if in this plot you see carefully, for the low pressure system, for the same height, from this height, let us say this is A, to this height which is B, for the same height, and the temperature range, see how it varies. Okay, so we can see here that for the low pressure system, the difference between the temperature is quite high, while for the high pressure system this plot will be this way. For the high, so for the high pressure system, high pressure, because in this case, the for the same height, the uh, difference in temperature will be low, so it will be a less steep plot, and for low pressure system it is more steep. Okay, all right, let us move ahead now. So I hope you understood what is the impact of pressure systems on the uh, change in the temperature. Vertical distribution. Now if we have this high pressure system, the second plot, if you see over here, here for a range of temperature, see there is some height over here. For the same range of temperature for the low pressure system, it will be a different case scenario. So you have to understand that once the uh, pressure is low, the temperature gradient, that range will be that difference will be more, so it will be a steeper curve. If the pressure is high, the gradient will be less, because due to the compaction the air temperature starts to rise, so the difference between the lower height and the higher height will be not much. Okay, so this change in the temperature with height or altitude, it is called as the lapse rate. And how is lapse rate defined? It is basically the rate of decrease of atmospheric temperature with altitude. But when we say this decrease of atmospheric temperature, please be careful that we are talking specifically about the troposphere. Troposphere. Once we go into the details of the other layers of atmosphere, we'll see that the behavior of this change in temperature is different. So in this diagram, we can see here that there is a lapse rate of around 6.4 degrees Celsius per kilometer. Now, we know that the total height of the troposphere, and which is bounded by tropopause at the top, is around 14 kilometers. So here we can see that from surface of the earth, as we go up in the atmosphere, there is a consistent drop of temperature at the rate of 6.4 degrees Celsius per kilometer. But this is the average value. We assume here to calculate this value, we say that this is the normal lapse rate. To get to this value, we assume that the motions in the air column are very, very less, and the temperature difference is the energy transfer is not much. But this is an idealistic condition which rarely happens in the atmosphere. Therefore, the concept of environmental lapse rate comes. So the actual lapse rate is always different than the normal lapse rate. Now that we have got the lapse rate, the normal lapse rate, so let me write it over here, that it is this value is for the normal lapse rate, normal lapse rate, while the actual lapse rate or environmental lapse rate, they are different than the normal lapse rate. Now, higher the altitude, lower is the temperature. This is a generalized condition. Lapse rate varies with height, location, or season. So, the lapse rate at equator will be much different than the lapse rate at the poles. The lapse rate at the sea level will be different than lapse rate at the mountainous regions. Lapse rate will be different in the summer season, and lapse rate will be different in the winter season. So, uh, there are several as I mentioned in the beginning, that there are several factors which control this lapse rate. So this value of lapse rate is, it keeps on changing based on the latitudinal position, the altitude, and the seasons, means the time of the year. Now, an interesting fact, if you see over here in this diagram, is that this line, that higher the altitude, lower is the temperature, it does not hold valid after this height. You can see here that here till around 13 kilometers there is a consistent drop in temperature. But as soon as we reach the upper part of troposphere and as we cross the tropopause, the temperature starts to rise in the stratosphere. There is a reason for it, that as in the troposphere we have the majority of the gases. So these gases, they have their own way of absorbing and radiating heat. Plus, as we go up in the atmosphere, the gases, they become rarefied, they are rare, while closer to the surface they are denser. But in the stratosphere there is an important gas which absorbs the solar insolation or solar heat, that is ozone. We all know that the ozone layer is a typical stratospheric layer. So there it is one of the major reasons that the temperature of stratosphere starts to rise after the tropopause. Now, another important thing which we all should also understand, that the lower temperature, the lower layers of troposphere, these lower layers of troposphere, they have higher temperature than the upper layers of troposphere. Means that as we go from lower levels of troposphere to higher levels, there is a consistent drop in the temperature, which means that the direct source of atmospheric heat is closer to the earth's surface. So try to understand this point, that the source of atmospheric heat atmospheric heat is the terrestrial radiation and it is proved by the fact that the temperature of the layers of troposphere decreases as we go from the lower layers to the upper layers. It means that if the distance from the source of energy will be more, it will be less heated. It is true. So when the surface of the earth is heated, so the layers closer to it will be more heated than the layers far away from it. It means that the terrestrial radiation is the major source of the atmospheric heat. Okay. Moving ahead, so as I mentioned about the normal lapse rate, environmental lapse rate, basically the lapse rate, there are of three main kinds. Environmental lapse rate, which is the rate of decrease of temperature with altitude in stationary atmosphere at a given time and location. So as we assume over here that there is not much movement of the air. So this is normally uh, found to be 3.56 degree Fahrenheit, or 1 point, or close to 2 degree Fahrenheit per 1,000 feet. We can always calculate it in different scales, or the average temperature lapse rate is of 6.5 Kelvin per kilometer. Like that, you can always calculate it from the sea level to 11 kilometers, means we are now reaching the upper height of the tropopause. While there is another important lapse rate called as adiabatic lapse rate. We all know what are adiabatic processes. So if you look at the adiabatic lapse rate is of two kinds: the dry adiabatic lapse rate and wet adiabatic lapse rate. So what happens over here? Let me just explain. Imagine that this is the surface of the earth. This is the surface of the earth. Here, due to the solar insolation and due to the heating, so let us call it as heat. Now this parcel of air starts to rise. This air gets heated and rises. As this air starts to rise, so the surrounding atmosphere is at a relatively lower temperature. So this air, as it rises, it starts to expand. So once this air starts to expand, it will need some space. So this air, the energy of this air will be starting to push दी एयर पैकेट अराउंड इट, यानी जब ये हवा गर्म होकर के ऊपर उठती है तो इसका टेम्परेचर भी ज्यादा है, इसकी जो सराउंडिंग एयर मास है वो उससे ठंडी है। अब इस एयर को, जो राइजिंग एयर है, इसको एक्सपैंड करना है। एक्सपेंशन के लिए ये क्या करेगी? इट विल डू सम वर्क, दैट वर्क विल बी एक्सपेंशन ऑफ द कॉलम। In that case, उस केस में the heat in that air is not transferred to the surrounding, but rather that is spent as work. So the heat of the rising air is used up as work to expand and push the surrounding air mass. Surrounding air mass. So what will happen? The energy contained in that rising air mass is not being given to the surrounding air mass, but here this actual air mass is losing its energy. यानी जब वो काम कर रहा है तो वो हीट डायरेक्टली अगल बगल के एयर मास को नहीं दी जा रही है, बल्कि वो एनर्जी वर्क के फॉर्म में यूज अप हो रही है। तो क्या होगा कि ये जो एयर मास, जो राइजिंग एयर मास था, उसका भी टेम्परेचर घटेगा। इसी को कहते हैं एडियाबेटिक प्रोसेस। आप सभी लोग केमिस्ट्री में, फिजिकल केमिस्ट्री में आपने इसको पढ़ा होगा कि what is adiabatic process. So what happens here is that once a dry parcel of air, means the air which has no humidity, it rises, it cools with a rate of 3 degrees Celsius per 100 meter. This is called as dry adiabatic lapse rate. But once the uh, air mass has water in it, water vapors, it is humid. So what will happen? As it goes up, the work is being done, plus the water droplets in this, the water vapor in it starts to condense, यानी जो उस एयर मास के अंदर जो वाटर वेपर है वो धीरे धीरे कंडेंसेशन होगा। तो फिर क्या होगा? द हीट ऑफ कंडेंसेशन which will be released will be given to surrounding air mass. As a result, during the moist या wet adiabatic lapse rate, the heat is provided to the surrounding air mass by the rising air mass. जो हवा ऊपर गई उसके अंदर जो वाटर है, जब वो अभी वेपर फॉर्म में है, जब वो कंडेंस करेगा तो उससे जो लेटेंट हीट ऑफ कंडेंसेशन निकलेगा, वो हीट अगल बगल के जो एयर मास है उसको भी गर्म कर देगा। अब क्या हुआ कि जब वो भी गर्म हो गया तो द टेम्परेचर ऑफ दिस राइजिंग एयर मास, इट cools down slowly. It cools down slowly. So you can see over here that in the previous case, there was this uh, 5.4 degree Fahrenheit per thousand feet was the change in the was the dry adiabatic lapse rate, but in case of wet adiabatic lapse rate it is less. तो आप ये देख सकते हैं इस प्लॉट में कि the dry adiabatic lapse rate it is having a steep curve or steep temperature gradient, while this is having a gentle or less steep temperature gradient, the moist diabetic lapse rate. ऐसा क्यों हुआ? क्योंकि जब एयर ड्राई है, जब वो पूरी तरीके से ड्राई है, तो जब वो राइज करती है, तो उस केस में वो अपने सराउंडिंग एयर मास को गर्म नहीं कर पाती है। क्यों गर्म नहीं कर पाती? क्योंकि जब ये एयर राइज करती है, ड्राई एयर जब ये राइज करती है, तो ये सिर्फ एक्सपैंड करती है। उस एयर के अंदर जो भी हीट या एनर्जी अभी स्टोर्ड है, इट इज बीइंग यूज in form of work. But once the moist air mass rises, जिसके अंदर जो वाटर वेपर है, जब ये ऊपर जाती है हवा, गर्म हवा जब ये ऊपर जाती है, तो वो वाटर वेपर वाटर के फॉर्म में कंडेंस करता है। तो वो जो हीट ऑफ कंडेंसेशन है उससे सराउंडिंग एयर मास भी गर्म हो जाता है। ऐसे केस में जो ये ओरिजिनल ऊपर उठने वाली एयर मास है, इसके ठंडे होने के से कूल डाउन होने का रेट कम हो जाता है। इस वजह से जो वेट एडियाबेटिक लैप्स रेट है वो कम होता है ड्राई एडियाबेटिक लैप्स रेट की वजह से। नाउ इन दिस प्लॉट ओवर हियर यू कैन सी that the once the rising air mass it cools more slowly than the environmental lapse rate, it means that the atmosphere is unstable. Now what happens over here, that once the environmental lapse rate uh, and the rising air mass, the relationship rising air mass. So what happens? As this air rises, as this air rises, if its cooling is slower than the environmental lapse rate, if the cooling of rising air of rising air is slower than environmental lapse rate, then this is the situation of unstable atmosphere. Unstable atmosphere. So what will happen over here? Once the environmental lapse rate is different than the rising air and rising air is cooling slowly, it means that the air will remain warmer. So once the air remains warm, it will allow the rising air to go more and more up. So in this case, cooling of air, rising air is slower than environmental lapse rate. So in unstable atmosphere, the air parcel continues to rise, or continues to ascend. While if the cooling of rising air is faster than environmental lapse rate, it is the situation of a stable atmosphere. Stable atmosphere. So what does it mean? It means that now the air which was rising, it has cooled faster, so it has become cold now. So the height, the movement of this air to more height will be restricted. So stable atmosphere restricts the vertical motion. The vertical motion of air passing. Air passing. So if you see over here in this case, once the moist adiabatic lapse rate will be there, then here the atmosphere is absolutely stable. while once it is dry adiabatic lapse rate is there, then it is absolutely unstable. Means here in this case, in the absolutely unstable atmosphere, the rising air is cooling slowly than the environmental lapse rate. So here the air continues to rise, continues to rise, while in this case vertical motion is restricted. Okay, all right. So what are the various types of variations in the lapse rate? Let us see a few examples. Now let us say that there is a valley in a mountainous region, and this valley is filled with cold and dense air. So if say let us, this is a mountainous terrain and this is a valley. If this valley is filled with all cold and dense air, then the lapse rate will be lower. So let me just change the color. Cold and dense air in the valley. So it will be, oh, sorry. It will be low lapse rate. Now, why we are saying low or high lapse rate? So let us say that at the base, the temperature is T1 and at some high temperature is T2. If the difference between these two is very large, it will we will call it larger lapse rate. If the difference between these two temperatures is less, it is lower lapse rate. Now, second case is that in the upper part of atmosphere, so advection of cold air in upper atmosphere upper atmosphere, it will be again causing lower lapse rate. What does it mean? It means that whenever the cold air is present or the temperature has got lower, it will lead to the less difference in the temperatures at height and at the base. Therefore, it will be the lower lapse rate. Sometimes during the winters, many of you must have noticed it, that on the ground floor, let us say this is your building. This is ground floor, first floor, second floor, third floor, fourth, fifth, whatever. So people who are here, they experience extreme cold, chilling cold. But if you ask the people who are sitting over here at the higher height, then it will be less cold, relatively warmer. So why does this happen? It happens here that the uh, air which is in contact with this earth, it will be extremely cold. So once this air gets quite cold over here, again the lapse rate will be less. So this, the difference here and difference here, it will be not much. Secondly, why people over here feel less cold? Because of a phenomenon called as temperature inversion. We'll discuss it in detail in the next lecture, but this is a fact that if you ask a few, in a high rise building in colder areas, if you ask people living on the top floor or the higher floor, they will say that they feel lesser cold than the people who are in the lower floors or the ground floors. Okay, now imagine that the air near surface become warmer in summers. So what will happen if this is the earth's surface? If the air here gets warmer, so as compared to that, the air in the higher levels will be cooler, cooler over here. So the gradient of temperature will be quite steep. So in summers, it will be lapse rate will be more because of the very less specific heat of the earth. It gives the of the continents, it gives heat to the lower air very quickly. They become extremely warm and they rise very fast. As they rise very fast in the higher atmosphere, they lose their heat and they become cooler very fast. So this difference in the temperature, it gives us a higher lapse rate. Okay, so these are a few conditions which are which tell us about the variations in the lapse rate. Okay, another important feature here is temperature inversion. I'll just touch upon it and we will discuss temperature inversion in our next lecture. So as we start going up in the atmosphere, I have shown you that diagram. As soon as we cross the troposphere and we enter the stratosphere, stratosphere, there is a difference in the way the temperature varies. So, in as soon as we cross the tropopause, after some height, there is an increase. The temperature starts rising. This is called as the inversion of temperature. So the inversion of temperature needs to be studied in detail. It's a very important point and has a very significant impact on the atmospheric and meteoric phenomena. So if we look at this vertical distribution of temperature, vertical distribution of temperature of atmosphere. If you see over here, the troposphere, it sees a drop in temperature after tropopause till the height of around 20 kilometers. It is gone. There is no change in the uh, 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 temperature, or the lapse rate becomes zero, and after that we see there is a rise of temperature in the stratosphere. So this layer, it is called as the inversion layer. Inversion layer. So this lapse rate, it is important phenomenon, and it helps us to understand how the temperature variation in the atmosphere takes place. It also controls some important events and phenomena like jet streams. So we need to understand what is the temperature inversion and the vertical distribution of atmosphere. So questions from this lecture uh, in the net exam may be asked about the uh, wet adiabatic and dry adiabatic lapse rates. Their values may be asked, and they may ask you at uh, once we are near the poles, then how the variation occurs. So uh, once we are near the equator, then how the variations occur, where the lapse rate is more. Is it at the equator or is it at the pole? So in which season the lapse rate is lower? Is it in winter or in the summers? So the common questions which may be asked in the exams with this topic, they will include the a variation in the lapse rate according to season, according to latitudes, and according to height. Now, I could have included temperature inversion in this lecture only, but then I realized that it is a very, very important topic and it given in quite detail in the climatology books. So we will do that in the next lecture. I have started this Telegram channel of mine also, CSIR JRF Geology Group, and you can get connected to me there, and I shall be happy to provide you all assistance, including books and not books actually, but the notes and study material for it. Till then, guys, stay safe, keep enjoying studying for net examination. Thank you.